I got a piece of cable here, and they put labels on this cable. So it shows who makes it, UL listed, shows the size, that 600 kc mil is the size. Voltage on here somewhere. There you go, 600 volts, CT rated, what it's made out of, THWN2, IEEE 1201, that's a flame test that it passes. Date. You'll hear people say all the time, left and right, you'll hear people say a certain size cable has a certain ampacity. So this 600 kc mil cable, if you go ask people who know what they're talking about, they'll tell you this can carry a certain amount of amps. It's a 600 volt rated cable. Why doesn't it have the amps too? Doesn't that seem useful? So people who know this stuff will tell you this has a set ampacity, one number, and that's all they'll say. The ampacity of this cable is whatever it is, 500 amps. Why don't they put the ampacity rating right on the outside of the cable? There's the volts is right there. Why don't they just put the amps right next to the volts? Wouldn't that help people build things better and more safely so that they can check the amp rating right on there? So these fixed ampacities of this cable can be looked up in codes and standards. They have tables that show you this size cable has this much ampacity. And if you get the data sheet for this cable, which is available online, it will show you what the ampacity is of the cable. So why don't they put it on the outside of the cable? Are they messing with us? They want my life to be hard. That's what it is, I'm sure. I want to see the ampacity right there, so I don't have to look it up in a table. How easy would that be? I could just look right on the outside of the cable. So as you dig deeper into cable ampacity and current, why does a cable have a limit on current in the first place? So the voltage limit on cable is a result of the amount of insulation around the conductor that can operate safely, and you could touch the outside of this cable and that voltage is not going to leave the conductor and meet up with your hand, which you don't want to have that happen. The limit on ampacity of cable is a thermal limit. This conductor can carry as much current as you want it to carry, but if it carries too much for too much time, it will exceed temperature ratings and the insulation will start to melt, or if it gets hot enough, the conductor itself can start to melt. So as we look into ampacity further, we find out that those tables we look at, that everybody uses the same number for the same cable of ampacity, it has all these assumptions at the bottom of the table and even at the top in the description. So some of those assumptions are physical configuration, if this cable is underground or above ground or in a conduit, or if it's open to free air, there's different tables or there's adjustment factors for that. Even the conductor material affects the ampacity. So this conductor is copper. They make aluminum conductors as well, and they have different ampacity. And then ambient conditions, the outside air temperature, even the cable specification affects the ampacity. So for this cable size, this is a single conductor cable. All of these copper pieces you see in here act as one conductor for one phase. If you wanted to do 3-phase power, you might get a 3-conductor cable, which is an overall jacket, and you could have 3 of these cables within an overall jacket. That affects the ampacity of the cable. There's grouping derating factors also, that if this cable is installed underground with a group of other cables nearby, that heat will accumulate in the soil, and this has to be derated. Derated meaning rated with a lower ampacity. Even the depth that you put this cable underground affects its ampacity rating. So that is why there is no ampacity rating printed right on the cable. So if somebody tells you a certain cable has a universal ampacity with no follow-up assumptions, you need to ask yourself some questions, and you probably need to ask them some questions too. And you should be very wary of anybody who states universal ampacities for certain cable sizes and types. So I hope to get into more detail on the more advanced levels of how you calculate the ampacity of cable for different situations.